All right, everyone, in this problem, we are going to be calculating flow, specifically how much water is flowing through a pipe given some certain conditions. So what we've got here is we have a water pipe. We've got a diameter on the water pipe of, let's say, 6 inches. Remember, the diameter is that line that goes straight down a pipe. That's how we categorize pipe size. We got a velocity in this case equal to 1.3 feet per second. And we're trying to figure out what is our flow rate Q in both cubic feet per second and gallon per minute. So the first thing we need to start with is our formula for Q. Now, if you don't remember that, it is located on both of those formula sheets for the state, the new one and the old one. This video is in 2025 where the state is transitioning from the old to the new. So flow rate Q, we need to remember, okay, what is Q equal to? Well, Q is equal to our area of our pipe times our velocity. Remember, not volume. Q equals AV, that's velocity. Now, we're directly given velocity of 1.3 feet per second. Fantastic. What we're not given is the area, but thankfully we can calculate that. So remember, in water math, we're always going to use that 0.785 times the diameter squared. That's how we're going to figure out area of our circle. In this case, the diameter is 6 inches. Now remember though, when you plug in area into the QAV formula, you always want to plug in area in square feet. So when we're given our diameter in inches, we need to convert from inches to feet before we plug that in for our diameter. So how do we do that? Remember, anytime we've got inches, we can always convert to feet by dividing by 12 because there's 12 inches per every foot. So in this case, it's a nice even 0.5 feet. So that's what we're going to plug in right here. So 0.785 times 0.5 feet times 0.5 feet. So now we can plug that into our handy dandy calculator, 0.785 times 0.5 times 0.5. And that's going to give me an area of 0.19625 square feet. That's the total number that my calculator reads. Now, the best thing you can do is just leave that whole number in your calculator. You could round it, and if you did round it, say 0.196 square feet, you're going to get a very similar answer in the scale at which we're talking about. But the best thing you can do is just leave that number in your calculator and let it roll over. So that's what I'm going to do. I'm going to leave this full number in here. Remember, this is now my area that I'm going to plug in over here. 0.19625 square feet. Area times velocity. So I'm going to multiply, take that, multiply times 1.3 feet per second. That's going to give me a flow rate of 0.255125. That's the full number. And my units are cubic feet per second, right? I have square feet times feet per second. So the square feet times feet gives me cubic feet. I'm left with seconds on the bottom. This is my flow rate. Anytime we use the standard QAV formula, you're going to get your answer in CFS, right? CFS. Now you might abbreviate this now or round this to 0.26 CFS. What if we want to report our answer in GPM though, in gallons per minute? Well, we need to convert. So I'll use the shorthand. I'll use the 0.26 for ease of writing this, cubic feet per second. Now I need to convert to gallons per minute. So first let's take care of the volume component and then we'll take care of the time component. So first thing I'm going to do is set up my conversion factor. Even if I don't know what I'm trying to convert, I can figure it out this way. I need to get rid of cubic feet. Remember that whatever I'm getting rid of, it needs to go on the opposite side of my conversion factor. So cubic feet's up top on this side. It's got to go down below. Cubic feet, what am I trying to bring in? I'm trying to bring in gallons. I know, or I can look at my formula sheet. I know there's 7.48 gallons for every 1 cubic foot. Great, I've canceled out cubic feet. If I stopped here, I'd end up with gallons per second. That's not what I want. I want GPM, gallons per minute. So now I got to take care of that seconds component. Seconds is on the bottom here, so it needs to go on the opposite side of my conversion factor. I'm trying to bring in minutes. I know there are 60 seconds in every 1 minute. This allows me to cancel out seconds. So if I look at my units on the top, I'm left with just gallons. My units on the bottom, I'm left with just minutes. So now I can plug it in, 0.26 times 7.48 times 60. And that gets me to 116.7 gallons per minutes. Now again, depending on where you round, this final number is going to be a little bit different, but it should be close enough to what your goal is or what you're going to see, say, on your exam, whether it be one of my exams or say your state exam. Now, for those of you interested in the shortcut, I have a separate video on that, but I will just tag it here real quick. If we look at this conversion, the 7.48 and the 60, this is always going to be the same. Converting from CFS to GPM, we're going to do it the same way every time. So if I plug in 7.48 times 60, I will see that those two numbers equal 448.8. And that is the shortcut you can use to go from CFS to GPM by just multiplying by 448.8. And again, that number is now on the new formula sheet. It was not on the old one. This video is made in 2025, so we're transitioning from one to the other, but it's closer to the very top of that conversion sheet. It says 1 CCF is equal to 7.48 or 448 GPM. All right, so that is finding flow rate Q given pipe dimensions and a velocity in both CFS and GPM.